drug discovery fails early and often not because we lack ideas, but because screening and prioritization is slow, expensive, and noisy. What teams really need is a fast, explainable way to rank molecules and focus lab time on the best candidates. Hi, my name is Abhishek Nandi. I am doing my PhD on bioinformatics AI from Vignan University and also working as a chief data scientist. So let's have a look at this application. So this is the page for the application that we have. So drug discovery is expensive, screening is noisy, decisions must be made fast. So this is DendriteScreen, a lightweight drug discovery screening app built with RDKit and powered by PerforatedAI dendritic optimization. It trains a molecular classifier using fingerprint features, then lets you screen new smiles in seconds with clear visuals and chemistry context. So here is the app. So let's go through it. We start by uploading a simple CSV file. So we have the CSV file that's already been created, but you can also use the BPB benchmark dataset. We featureize molecules using Morgan fingerprints plus optional physiochemical descriptors like molecular weight, log P, TPSA, HBDA, and HBA. Then we split the data using scaffold split, which is important in chemistry because it tests whether the model generalizes to new molecular scaffolds. So first we'll upload a file. We click on browse. Here we have a CSV file that's been already there. We'll click on select. So you can select this. So see how the application is running here. So let's go to the factor. This gives a preview of how the CSV full file looks like. There are rows, 488 rows and 2 columns. And you can the featureization is valid molecules, it's being shown. Scaffolding, you can also use random split. Now here is what it makes unique. So during training we enable perforated AI dendrites which can restructure this model to improve learning efficiency. We can run baseline versus dendrites side by side to see whether dendritic optimizations improve validation, AUC, and scalability without changing to dataset or features. So perforated AI dendrites, dynamic restructuring for better learning. So we can also see we can add the basic RDKit descriptors, and if we go here, we can also add the dendrites that are needed. We can also check for the baseline versus dendritic comparison. So as we click on the start training phase, you'll see the app starts working on its own. It goes through the entire application. It's a training pipeline that you see over here. So you will see it creates the chemical space 2D PCA projection with the Morgan prints. So once trained, we switch to a screening tab, and also we can paste the molecules. So let us see what we have got from the details over here. So here more of then you get all the information, the training history that you want to see. So all of the details are over here. You can also check for the chemistry visuals like RDKit. The information is there, how it's fared during the training. You also get the chemical space 2D PCA projection for the molecules that have been selected. Interpretability, descriptor importance is also there. Now the most important part in this application is how we use this as our interpretability and decision support. So once trained, we switch to the screening tab and paste new smiles or upload a library. So if we go here, as you can see, we have the screening tab here. We can also check for all the molecules that are there. We can also input the smiles, see how effective it is, and it can act as a complete solution for our the molecular docking or molecular creation of the new molecules here. Now if I consider the smiles, so smiles are the representation of the chemical compounds that are used. I will use this and Here you will see I will paste all the smiles line by line, and now if I just click on score, you will see the entire application that we have trained on, it starts working. So here we click on the score option, and you have the ranked results for all the molecules. Okay, here also you can also see the hits ratio. For a quick scientific intuition, we also show RD kit property summarizes and 2D structure grids for the top candidates. To make the results actionable, DendriteScreen adds chemistry context. Why this hit? Snapshot compare a molecule's property against the training medium. So you immediately see if a hit is unusually lipophilic, heavy, or a polar. This helps researchers prioritize compounds with the right profile for their project. So why this hit? Property deltas versus training median. Okay. So now turns DendriteScreen turns raw smiles into ranked explainable the screening decision, combining the reliability of RD kit with the optimization features of perforated AIs. Um, and optimization power of perforated AI dendrites too. Next, we'll expand to the multi-task ADMT prediction, larger library screening, and deeper graph-based models. So you see, it's a faster screening, practical interpretability, perforated AI advantage. So you see all the details why this hit was there, and everything is also information wise given, and you can get all the results from this. So this is a complete web app that's being used for drug discovery purpose, and it is powered by perforated AI to improve the dendritic capability of uh, the compounds that are used for training, and it's very useful too. So that was our entry for the challenge. Thank you.